Hello, hello. This is section 4 of Unit 3, Angles with Proof. So you need to go to page 10 and start there, page 10 in your notes. And so that's the notes that have the orange cover. Okay, so page 10, section 4, Angle Relationships Application. So far in Unit 3, we have talked about fundamentals of angles. So being able to identify which part is the vertex, which parts are the rays. So the sides, remember, are rays. And then being able to rename angles using either 3 letters with the vertex in the middle, the vertex, and a number if one is labeled. Remember, the only time you can use just the vertex is if it's the only angle at that vertex. Okay? So we took a CFA over that, and it also had 5 different angle relationships. And so we will talk about those 5 angle relationships more later on this week. Specifically, we're going to talk about 3 different theorems, postulates, definitions, 2 definitions and a postulate today actually, and apply those. So this is where we're starting our application, so information for application strand. But as I hinted to earlier, that those 5 angle relationships are also definitions, theorems, postulates that we will be talking about as well. Okay, so on page 10, we're going to start with the definition of congruent angles. And so congruent angles are angles that have the same measure. So just like with segments, if 2 angles are congruent, then we can say their measures are congruent. So, or are equal. Sorry, let me rephrase that. So if 2 angles are congruent, notice this notation that you just have the angle symbol with the congruent symbol. If we know those 2 angles are congruent, then we can say that the measures of those angles are equal. So again, when I talk about congruent, I'm talking about the physical angle. So the rays and how they're placed in relation to one another at that vertex, and then comparing it to the rays and how they are compared to one another at another vertex. Okay? Whereas if I use the equal sign, I'm talking about the measure. So in this example to the right, I see that I have 2 angles that are 65 degrees. So when I say that, oh, these 2 angles have the same measure, I would use equal. If I want to look at these 2 angles and use that pink congruent symbol, then I'm saying that those 2 angles are congruent. One way to write a congruent statement is to use those numbers. So notice here I've got angle 1, here I've got angle 2. So that's how I can say, oh, angle 1 and angle 2 are congruent. But if I'm using 3 letters, then I would use E as one vertex, B as the other vertex. I would say angle ABC, so A to B to C, is congruent to angle D to E to F. There I'm saying those 2 angles, the physical angles, are congruent to one another. So we have a couple of practice examples. One great idea here, so I'll do practice example 1 with you. And then examples 2 and 3, I would say once I'm done with 1, I would pause, because without even doing a lot of work, you probably already know how to do example 2 and 3. So I would pause in between each example and try it on your own first, and then check it. And so you would click play and then check to see, hey, am I setting this up correctly? And then am I doing the algebra correctly to solve for x or for the angle? Okay, so for example 1, I want to identify 2 sets of congruent angles. For this, you are looking for the number of arcs. Okay, so I notice here that, let me switch my thickness of this, that I see 1 arc here, 1 arc here. So that tells me that these two angles, QMP, that's got one arc, and angle PMO, those two angles are congruent. So if I want to write a congruent statement, I'm going to say angle, again, this is too thick, so I'm going to say angle QMP is congruent to angle PMO. Those two angles are congruent. That is one congruent statement. Okay? I could have flip-flopped the two angles. I could have said angle PMO is congruent to angle QMP. That would have been perfectly fine. I also could have switched the Q and the P around in this first angle, and I could have switched the P and the O around in the second angle. Okay? The second pair of angles that I see are congruent would be the ones that have the two notches. So the two that I'm highlighting right now in orange, those two both have two arcs right there. So that's telling me that those two angles are congruent. So one angle is angle LMQ. So notice M is the vertex, so M is in the middle. And then L and Q can be flip-flopped. And that angle is congruent to the other one that has two notches. Angle OMN. Angle OMN. I am sorry for those bars right there. Okay, and again, the O and the N could have been flip-flopped, but M must be in the middle. Also, I just have the angle symbol in front of both sets of three letters with the squiggly over the equal sign to represent congruent, since I don't know their measures and I'm not talking about numbers. If you think that you're like, okay, I understand that two angles are congruent because I see congruent symbols, feel free to pause this video right now and try example 2 on your own. Okay? If you're still not quite sure, just keep on watching, and I would recommend pausing after example 2 so that way you have a chance to try it on your own before I show you how to do that one as well. Okay, so example 2. First thing I noticed when it wants to know the measure of each angle is that in the end, I need to state what the measure of each angle is. Okay, so it's not just solving for x. So I know that. Then I look at the picture, I look at the diagram, and I see that angle NML has one arc at its angle, and that PQR, angle PQR, also has one notch. So that tells me that angle LMN is congruent to angle PQR. So in my head, that's what I'm thinking. These two angles are congruent. And by the definition of congruent angles, so this is an example of using the definition of congruent angles, I know that the measures must be equal. So the measure of angle LMN must be equal to the measure of angle PQR. Since those angles are congruent, then the measures must be equal. Okay? So if those measures are equal, then I can go and substitute values in. But I first have to know that the measures are equal before I can substitute numbers in. Right? So I see measure of angle LMN is this 5x plus 7. Okay? And then I know that the measure of PQR is this 3x plus 23. So then, since those two angles are congruent and their measures are equal, I can set those values to equal to each other. So I set 5x plus 7 equal to 3x plus 23. Okay? From there, I'm going to solve for x. So to solve for x, I need to try to get all my x values on one side of the equation, and any constants, so anything without x, on the other side. So to do this, I see 5x on the left, 3x on the right side of the equation. I like to keep things positive, so I'm going to subtract 3x from both sides, and I get 2x plus 7 on the left. 3x minus 3x would be 0. And so then I'm left with 23 on the right. From there, I still want x by itself. I want to isolate that x. Right now, I can't do anything with the 2 that it's being multiplied by, but I see I'm adding 7 to that. So in order to undo that addition, I think, how do I undo addition? I subtract. So I have to subtract both sides by 7. And when I do this, the left side will only have 2x, and 23 minus 7 is 16. To get x by itself, I divide both sides by 2, so I get x equals 8. It would be really, really awesome if I was done right there. However, I only know what x is. But again, what I underlined at the beginning is I want to know the measure of each angle. Okay, so in order to figure that out, I need to substitute x, or substitute 8 in for x. Okay, so I see that measure of angle LMN is equal to 5 times x plus 7. Well, I know that x, right here, I know that x is 8. So I'm going to substitute 8 in for x. And then I multiply, then add. So 5 times 8 is 40, plus 7. I see, oh, measure of angle LMN is 47 degrees. So this one right here is 47 degrees. Now, since we're using the definition of congruent angles and we know that the angles are congruent, we could just jump and say, well, this is 47 degrees as well. It has to be if they're actually congruent. However, it is good to check your work to make sure you didn't make a mistake along the way. Better to do that now than later. So I know that the measure of angle PQR is equal to 3 times whatever x is plus 23. I'll put that in there. And I know x is 8. So I substitute that in. 3 times 8 is 24. Add 23. And you still get 47. So yep, I see both angles are 47 degrees. Their measures are equal and their angles are congruent. Okay, I would recommend pausing right now, doing example 3, and then coming back. Okay, hopefully you tried example 3. For this, we see, oh, these angles are congruent. So then that tells me that the measures of the angles are equal. Okay, only if I know that they're congruent can I then jump to measures being equal, and then I substitute the values in that I know. So again, measure of angle BHC is this 4x plus 5, so that's what I'm going to substitute in for the left side since I wrote measure of angle BHC on the left. So 4x plus 5. And then the right side, that right side there is measure of angle DJE, and I know that is this one right here, 3x plus 30. Okay. Using algebra, again, I want x's on the same side of the equation. So I'm going to subtract 3x, and I get 1x, or just x, plus 5 on the right, and then plus 30, so just the 30. Then to get x by itself, I see x plus 5. I want to undo addition, so I subtract 5 from both sides, and I get x equals 25. Okay. So to wrap this up, I want to figure out the measure of angle BHC, which is 4 times the value of x. I see x is 25. And I add 5. 4 times 25 is 100, 4 quarters, plus 5. Measure of angle BHC should be 105 degrees. I do the same thing with measure of angle DJE, and that's 3 times x, which I said is 25. We solved that. And then we add 30. So 25